28/J stepper motors, the most easily available stepper motor in our market today. 28/J is a unipolar motor which comes along with ULN 2003 driver. ULN 2003 is basically a Darlington pair driver which converts the 5-pin connection into a 4-pin connection. As you can see in the left bottom corner of our image, M is the rotor of our motor and there are 4 coils connected to it: pink, orange, yellow and blue. There's one more wire which is connecting all the 4 coils together, which is red. It is being given 5 volts constantly. To drive the motor, we have 3 different methods: wave driving, full stepping and half stepping. You need to give some high and low signal to these 4 coils to allow the driver to take some action on the motor. The first part is wave driving. In wave driving, only one coil is energized at a particular amount of time: blue, pink, yellow and orange. As you can understand from the table, only one coil can be energized at a particular period of time, and hence the amount of torque applied to the motor is minimum. So wave driving is not a practical application. Wave driving is always used for testing the motor along with your microcontrollers. The practical implementation of motors can take place in full stepping and half stepping. In full stepping, 2 coils are energized at a particular period of time: blue and pink, pink and yellow, yellow and orange, blue and orange. This is how full stepping takes place. Hence, the amount of torque applied in full stepping is the maximum. But the step angle is very high. To reduce the stepping angle, you can use half stepping, where the amount of torque is a little bit less as compared to full stepping, but the precision of the motor is very high as compared to full stepping. Half stepping is a combination of wave driving and full stepping. One coil goes high and then immediately both the coils go high. As you can see from the table, blue, blue and pink, pink, pink and yellow, yellow, yellow and orange, orange, orange and blue. This is a combination of wave driving and full stepping to give the maximum amount of precision but an intermediate amount of torque. So now that we have understood the driving methods, let us have a look at the motor from inside. There are 2 important parts in a stepper motor: rotor and shaft. Each of your calculation is based on your rotor itself. Your stepping angle is calculated on the rotor, and the number of steps is also calculated on your rotor. But this gets reduced to a very high extent when it comes to calculation of your shaft. Your rotor takes 64 number of rotations to complete only one rotation of your shaft. Hence, if you want to observe only one rotation of your shaft, your rotor internally should rotate 64 times. And 1.8 degrees of rotation is your stepping angle. So one step is of 1.8 degrees, but that is for your rotor. When it comes to your shaft, 1.8 degrees of rotor gets reduced to hardly 0.18 degrees of your shaft. Hence, we need to understand that each and every calculation of your rotor and shaft is based differently. Every calculation comes along with your rotor, but that acts differently on your shafts. So that's the major difference between rotors and shafts of a stepper motor. Please keep in mind that the calculations for rotor and shaft are always different. I've given a link in the description box below. You can download the code from there. This code is for Arduino Uno board to interface with the stepper motor 28/J48. The motor would be executing a full step condition and it would be completing one complete rotation. The number of steps required would be 2048. Hence, 2048 steps of the rotor would complete one rotation of the shaft. Hence, the stepping angle for my shaft would be 0.175 degrees, whereas the number of steps taken would be 2048 for the rotor. Thank you for watching.